Imagine a thought experiment where a creature is placed inside a sealed box with a device that has a 50% chance of releasing a deadly poison. Before we open the box, is the creature alive or dead? This famous scenario vividly illustrates one of the deepest puzzles in quantum mechanics, prompting us to question the very nature of reality when observing quantum systems. Schrodinger's cat profoundly impacts quantum interpretations by serving as a macroscopic thought experiment that highlights the measurement problem in quantum mechanics. It starkly demonstrates the seemingly absurd implications of quantum superposition, forcing physicists to confront how a quantum state, like a decaying atom, translates into our everyday classical reality, where things are either one way or the other. The core reason this paradox is so impactful lies in its extrapolation of quantum superposition from the subatomic to the macroscopic. In the quantum realm, a particle can exist in multiple states simultaneously until measured. The cat thought experiment directly applies this principle to a living creature, suggesting it could be simultaneously alive and dead. Different interpretations of quantum mechanics, such as the Copenhagen interpretation, which posits that measurement collapses the superposition, or the many worlds interpretation, suggesting all possibilities are realized in separate universes, offer distinct solutions to this measurement problem. Each interpretation grapples with the question of when and how this quantum state becomes a definite classical outcome. Understanding the cat paradox helps us appreciate the nuances and limitations of various quantum interpretations. It serves as a mental tool to evaluate which interpretations resonate most with our understanding of reality, or at least, which ones provide a consistent framework for explaining quantum phenomena. By engaging with this paradox, you can better grasp why quantum mechanics often defies our classical intuition, and why there is no single, universally accepted view of what actually happens during a quantum measurement. Interestingly, Erwin Schrödinger himself proposed this thought experiment in 1935 not to seriously suggest cats could be simultaneously alive and dead, but to ridicule what he perceived as the incompleteness or absurdity of the Copenhagen interpretation of quantum mechanics at the time. It was a critique designed to expose the gap between quantum theory and everyday experience. The concept of quantum decoherence, introduced later, offers a partial bridge, explaining how quantum systems lose their superposition due to interaction with their environment, making the macroscopic world appear classical without fully resolving the philosophical quandary of interpretation. Ultimately, Schrödinger's cat continues to be a central and provocative discussion point, not just for its dramatic imagery but because it compels us to think deeply about the fundamental nature of observation, measurement, and reality itself. It drives ongoing research and philosophical debate, pushing us to refine our understanding of the quantum universe and its profound implications for how we perceive our world.
If quantum tech fascinates you, like, subscribe, and keep exploring with us.